Hello friends, in previous lecture we have seen what is molecular symmetry, what is symmetry operation and what are the symmetry elements. If you want to know more about these concepts, then you can visit on the links that are mentioned in the description box. In today's lecture we are going to learn about rotational axis of symmetry. The rotational axis of symmetry is of two types. First type is proper or rotational axis of symmetry. If we carried out this symmetry operation on any molecule until the configuration is identical with the original one is reached, then such type of operation is known as proper or rotational axis of symmetry. The formula for the principal or proper rotational axis of symmetry is Cn is equal to 360 divided by theta, where this C is the cyclic, theta is the symmetry angle by which the molecule is rotated, then n is the number of times the molecule can be rotated for reaching its original configuration. If we rotate any molecule with this 360 degree, then 360 divided by 360, it gives the value 1, and therefore this C stands for cyclic and this 1 represents rotation through 360 degree. If any molecule is rotated with the angle 180 degree, then the formula becomes Cn is equal to 360 divided by 180. It gives the value 2. Therefore, I write here C2. Similarly, for 120 degree, 90 degree and 60 degree, these are the symbols that are used to indicate such type of rotations. Let's we learn the symmetry operations of BF3 molecule. If we consider this molecule, the central atom is boron and this first one is F1 atom, F2 atom and F3 atom. For our convenience, we write it as a 1, 2 and this 3. In this molecule, the angle between this F1 boron and F2 is of 120 degree. Therefore, this theta value in this case is 120 and therefore 360 divided by 120 gives the value C3. Therefore, we write C3 here as a principal axis. And always remember this principal or proper rotational axis of symmetry always has the value of n is maximum. Just see the rotation of this molecule. This is the principal axis and I rotate this molecule in order to get equivalent configuration. It means the skeleton of this molecule remains fixed, only the atoms are exchanged. Similarly, if I rotate again the same molecule in order to get equivalent configuration, the position of this atom is at this place. If I again rotate the same molecule in order to get equivalent configuration, then it becomes identical with the first structure. In this way, if you rotate any molecule in order to get equivalent configuration, the position of atoms change and one point or one axis is fixed, and this axis is highest fold axis. Therefore, it is known as principal or proper rotational axis. If we consider the example of water molecule, where this is the oxygen atom, this is first hydrogen atom and this is second hydrogen atom. If I hold these oxygen atoms at this center and I have to rotate this molecule in such a way that the skeleton of the molecule remains fixed, I hold this atom and rotate in this direction, it gives equivalent structure, only the position of the atoms here changes. Then if I again rotate this molecule in 180 degree rotation, then the molecule is identical with the first one. Therefore, the last rotation of any molecule gives the structure that is identical with the original one. Always remember this thing. We can rotate this molecule by 180 degree. Therefore, according to the formula of principal axis, 360 divided by 180 gives the value 2, therefore we can say C2 as a principal axis in this case. If I want to rotate this molecule has an angle of 90 degree between these two atoms. All atoms are similar, only I label with different colors as first, this is the first one, second one, third one and fourth one. All atoms are similar, only for our convenience I write it as a 1, 2, 3 and 4. As you know, the angle between these three atoms is 90 degree, therefore 360 divided by 90 gives the value 4 and therefore we called it as a C4 axis. If I have to rotate this molecule, then I hold this central atom at this position and I have to rotate this molecule in such a way that it gives the equivalent configuration. I rotate this molecule with 90 degree, all atoms gets exchanged. The skeleton of this molecule remains fixed, only atoms are changed. And if I rotate this molecule by 90 degree, then this axis or this rotation is known as first rotation of C4 axis. If I rotate this molecule second times, it gives this structure. Here only the atoms are changed, the skeleton of this molecule remains fixed. Again I rotate the same molecule, it gives this equivalent structure, and in last rotation it gives the identical structure. In this way, any molecule can be rotated by an angle. Highest fold axis is known as principal axis. In this case, C4 is the principal axis. Thank you.